Welcome back to the 10th episode of 12 integrals. And I'm outdoors today, as you can see, but I'll be back in very soon after I film this bit or something. And today I have a simple integral for you guys to solve, even though I'm in the mountains and whatever. But I want you to solve this integral. I want you to integrate natural log of x divided by 1 plus x squared from 0 to infinity. And there's a very neat trick to solving this one. I'm not going to tell you what it is just yet. I'll give you a bit of time and I will see you back in the usual place, I guess.
So this is the integral that we have. Integral of natural log of x divided by 1 plus x squared from 0 to infinity. And the trick that we're going to use to solve this integral is we're going to split this integral into two integrals, as I'll do right now. So rather than integrating from 0 to infinity, we're going to find two integrals. One from 0 to 1 of the same function, and another one from 1 to infinity. That's a very badly drawn infinity sign, I'm sorry about that. But from the same limit, like that. So now what we're going to do is going to take one of the integrals. Let's say we're going to try to find that integral. Not really find, but more like simplify that integral so that it's in a form which makes this whole question a lot easier. And I'm going to write this just to be explicit, right? I'm going to write that this is x equals 1, this is x equals to infinity. And you'll see how this helps in just a second. And so now what we're going to do is we're going to do a bit of substitution. I'm going to let x equal to 1 over t. And you'll see why as we do it, right? So if x equals 1 over t, then that means that dx over dt equals to minus 1 over t squared. This could be verified. I'm not going to show you how. You could probably figure it out yourself. And this also means that dx will equal to minus dt divided by, I hate this pencil, t squared. I'm going to change pencils. And so now I'm going to substitute all of these things back into this integral. So now it looks like this. So we'll be in the integral of natural log of 1 over t divided by 1 plus 1 over t squared times minus dt over t squared, like that. But it's also important to change the limits of integration. Before, we were integrating with respect to x, which is why these two limits are with respect to x. And so now we have to change it to be according to t, which is the variable that we're integrating over instead. So the bottom limit is x equals to 1. So if we change it, we have to put 1 back into this equation, and then we'll get 1. So here we're integrating from t equals 1, and then we're going up to x equals to infinity, which is the same as t equals 0. So our new limit of integration is from t equals 1 to t equals to 0. So now it's time that we, simplify this whole mess a bit further. So first we're gonna, take this minus sign outside like that. And then again, we're still integrating from t equals 1 to t equals to 0. And we also have these two t's, which could do some algebra at the bottom. And I'll just write that out and you could show it to yourself that it will in fact equals to 1 plus t squared. Now the top bit, what we have is we have the natural log of 1 over t. And I'll write this out as a little note like over here, right? That the natural log of 1 over t will equal to negative natural log of t. And for some of you, this log rule should be rather familiar, but if you're not really sure, then it's a similar reason why 1 over t is also written as t to the power of minus 1, because natural logs and pretty much all logs are just basically like the exponentials of a certain base, right? But alright, let's not worry too much about that for now. And so the top bit instead becomes negative natural log of t. And obviously we're going to be integrating this with respect to t. To tidy things up a bit, I'll move this negative sign in front of the natural log and I'll put it outside here. So now we have a positive integral of natural log of t divided by 1 plus t squared dt. The other thing that we could do is, because our integration goes from 1 to 0, and that's a bit ugly, we could flip this integration limit, but when we do flip it, the integral will instead become a minus. So we have a minus t equals 0 to t equals 1, which is the limits of integration, but just flipped around compared to this one, from the exact same function. That should be t. So, like that. And so now we have the integration and we can just put it back in there. So the first integration will not change it at all. It will still be the same. But the second integration, we have this instead. So we'll put this in. So it'll be minus the integration from t equals 0 to t equals 1. Now, of course, this one's integrating with respect to x, and this one's with t. But as you can see, both of these integration, in fact, does have something very similar to it. Because both of these integration ultimately are the same integral, right? This one and this one are basically just the same integral, but one is writing all the variables as x, and the other one is writing all the variables as t. So basically, these two integrals are the same. And because they're subtracting each other, they're going to cancel each other out completely, which means that this integral actually equals to 0. And so there you have it. This integral here, which looks really complicated, all basically just equals to 0. And that's the magic of integration and our integration tricks. Anyways, that is another episode of 12 integrals, and I'll see you again tomorrow. Goodbye.